All right, party people, Honors Math 1 lesson this week for simplifying expressions with exponent rules. We're going to have a couple of videos this week. Simplifying expressions using exponent rules, naming polynomials, and solving multi-step equations. Okay? All of them are posting today. And something I didn't think about last week when I was telling you that your notes would be due on Monday for participation is that if I give you 3 videos, I really don't want you to have to submit them all on Monday, the notes, because my intention is for you to kind of spread your work out, to take the notes for the first lesson, to do that work and make sure you understand it, and then go on to the next one. Does that make sense? So I'm going to go back and make only this first lesson's notes due for participation on Monday, and then I'm going to make the next one due on Tuesday and the next one due on Wednesday. Okay? That's just to give you more time to do it so that you don't have to rush through your notes on Monday, but you can do your notes for the first lesson and then do your assignment for the first lesson and kind of have some time there. Okay? So today, simplifying expressions with exponent rules. The assignments always are going to have the same exact name as the notes because everything, that way you can tell what goes with what, okay? We're going to update our table of contents, adding number 2, simplifying expressions with exponent rules. Okay, so if you need to pause. I'm going to keep going here, okay? I've got some things for you to copy on the number 2 page for simplifying expressions with exponent rules. So the first thing I want you to do is to pause the video and get this top half copied down. Let me see if I can't move it so you can see everything. Okay, so pause the video and you can get everything copied down, and then we will go through it. Start the video when you're ready. Okie doke. Simplifying expressions with exponent rules. So what we're going to do is we're going to take the exponent rules we learned before, and we did pretty basic homework with those, and we're going to take them into a little more complex kinds of problems, right? First, before I do some examples and show you what kinds of problems we're going to be working with, I'm going to clarify a few things, right? First thing here is clarifying the negative exponent rule. Okay? This is something that sometimes people have a hard time with. The rule tells you for when you're doing a quotient, to subtract the exponents and come up with a negative exponent. But then the negative exponent rule says, hey, don't have negative exponents in the answer, right? So it almost is telling us that we can't do what the quotient rule is telling us to do, right? But really what we're going to do is, if there's a negative exponent in the problem, or if you come up with a negative exponent while working a problem, we're going to think about moving that base with its exponent to the right location and removing the negative sign, right? Or think about leftovers, and I'm going to explain what I mean right now in the examples, okay? So the first one is pretty simple. Like, you just have a problem, x to the negative 3rd power, right? Or you're working on simplifying some other problem and you come up with x to the negative 3rd as you're working towards the answer, right? You really cannot have a negative exponent as your answer. So what we're going to do is move the base. The base is the x with its exponent 3. The negative is really just telling us that it's in the wrong spot. And so you kind of get used to thinking of it that way, right? The negative, its whole meaning is move this guy. Move x to the 3rd power to the bottom of a fraction. So once I move the x with the 3rd power down to the bottom of a fraction, I have done what the negative told me to do, and it disappears, right? A lot of people have a problem with that. They're like, well, where did it go? Or some people just write 1 over x to the negative 3rd power. They don't get rid of it, and then that's a problem, right? So just remember, once you move it where it goes, the negative disappears. So now we have 2 examples down here that kind of go together. And these are more about thinking of the quotient rule. Let me get a little closer here. We got x to the 3rd over x to the 5th power, right? Now, if we applied the quotient rule, we would subtract our exponents. 3 minus 5 is negative 2. And then we could say equals x to the negative 2 power, right? But then we would be in the same situation we were in up here, where we can't really use that as an answer, and then we would have to move it anyway. Does that make sense? There's another way of kind of applying your thinking that will help you just go straight there, and here it is. If you just think of this as a cancellation, right? There's 3 x's on the top and 5 x's on the bottom. Does the top or the bottom have more, right? Where will the leftovers be when they cancel? Okay, 3 of these on the bottom will cancel out the 3 on the top and leave 2 extra x's on the bottom, right? So the 2 extra x's will be on the bottom. The 3 on the top fully canceled out, so there's a 1 on the top, right? So if we think about leftovers, that works too. We're using the same ideas as negative exponents, but instead of making it into a negative and then making it back into a positive, we're just going straight to, let's keep it positive, right? If we just write the variable or the whatever base we're working with in its correct location where it will be left over, then we kind of avoid the negative exponent step, right? Now this one wouldn't be negative, but I'm just giving you this to let you say, think about where will the leftovers be, right? There's 7 on top and 4 on the bottom. If they cancel out, where will the extras be? The extras will be up here where x to the 7th is, because that's more up here than down there, right? How many more? 3 more, right? 7 minus 4 is positive 3, right? And positive 3 means it should be on top, but if we just think about where will the leftovers be and how many leftovers will they be? Are the leftovers on the top or are the leftovers on the bottom, and how many, right? So here's another little thing where people kind of have some issues. So I'm just kind of outlining a couple little scenarios where I see mistakes, right? X to the negative 2 is on the bottom, right? So the negative tells us the x squared is in the wrong spot and needs to move. It needs to move up to the top of the fraction, right? Do we need a fraction bar? Okay, let's think about that for a second. The x squared moves up top. The 5 is still up top. Nothing happened to the 5. Is there anything on the bottom? No. Technically, there's a 1 on the bottom, but we don't ever record a 1 as the bottom, as the denominator of a fraction, because that's what a whole number is, right? Okay, so now we got another example. X squared to the negative 3 power. So this is a power rule problem where we would have to multiply the exponents together to come up with the new exponent, right? 2 times negative 3 is negative 6. So technically we get x to the negative 6. But we can't have a negative exponent as our answer, so we need to then rewrite this as 1 over x to the 6th power. Does that make sense? And this is a step right here where once you're comfortable, you just skip over that, right? You say to yourself, 2 times negative 3 is negative 6, so the x is going to be on the bottom with the 6th power. Just got to get into that mode of thinking about what is the negative exponent telling me about the location. Okay, we're 8 minutes in. Let's keep moving on. The next thing that we need to talk about, and some people asked me questions about this from the homework, is what are we supposed to do with the number parts of a problem, right? And so numbers are going to operate in exponent problems just like they always have. The biggest problem people sometimes have are illustrated right here in these examples. This first example is 4xy in parentheses squared. And this means that every single thing in the parentheses is squared. So if we were working this problem, we need to remember the 4 gets squared, right? And this is just a number. We have to actually find the answer to 4 squared eventually. I'm kind of writing this out in steps because it's your notes. X has a power of 1 because it doesn't have a power showing. 1 times 2 is 2, so this is x squared. Y doesn't have a power showing, so that means it's 1. So 1 times 2 is 2, so this is y squared. We're not yet at the answer because this 4 squared part still needs to be worked out, right? X squared and y squared can't be worked out, so they're done, but the number part still needs to be figured, right? 4 squared is 16. So the answer to this is 16 x squared y squared. Now, obviously, you could have probably done that in your head. I'm just breaking it out for you to help you see. You got to remember to operate your exponents with your numbers and get answers. Some people oftentimes forget to do that because they're so focused on the exponent rules that they forget to do the things with the numbers, right? So in this problem, 15x squared and over 15x divided by 15x, We know that 5 over 15. Well, let's think about the x's. I want to show you something that you might not have thought about before. X squared on top and x on the bottom. They're going to cancel. And which one has more? Where are the leftovers going to be? The top has 2, the bottom has 1. So when they cancel, there's going to be 1 left on the top, right? Now, 5 over 15 is a fraction that can be simplified by dividing by 5. A lot of times in these kinds of problems, people make a mistake because they'll say 15 divided by 5 is 3. And then they don't know whether it should go in the numerator or the denominator. Where does the 3 go? Well, I'm going to tell you an easy way to figure it out is the same way that we were doing just now with the x's. Which one had more, right? The higher number, the 15, was on the bottom. So if you're just dividing these two numbers, you need to remember that the answer for that division will go in the spot of the number that was larger, right? So 15 divided by 5 is 3, but the 3 has to be down here on the bottom where the larger number was, right? And 5 divided by 5 is just 1, right? Do you need to write the 1? You can. If you wrote a 1 there, I'm not going to count it wrong. If you wrote x over 3, that's also correct, right? So there's another one over here just to show you that this works, right? 12 over 4. 12 can divide by 4, and that'll be 3. Where does the 3 go? Top or bottom, okay? Remember that it would always go where the larger number was, and the larger number was on top, so in this case the 3 is on top. The b's are going to cancel, okay? Where were the most b's to begin with? On the bottom. How many will be left over? 1. 1 will be left over on the bottom, right? There's 1 on top and 2 on the bottom. And so 1 minus 2 is -1, right? But instead of doing that quotient rule subtraction, get a negative exponent and then put it where it goes, we're just thinking about leftovers, like I said up top in the explanation, right? And putting the leftovers where they go. All right, so I think we're ready to get to some examples. You have a homework with 10 problems on it, and I'm trying really hard to show you examples of all the kinds of problems that are on that homework. Okay, and what we're doing here is we're basically just combining all these rules you've learned together into problems. The first couple of problems are just 2 of the rules together, and then down towards the end of your homework, like problem number 8 and number 9, combine all the rules. You're going to be using all the rules all in the same problem, right? So that's product rule, power rule, quotient rule, negative exponent rule, and zero power rule. We're just going to mishmash them all together and see what to do. Now, a lot of times I like to give you steps. Like step 1, always do this first, always do this next, always do this next. But in this case, it's really hard to do that. That's one thing that gives some people a fit kind of with exponent rules, is that for different problems, it makes sense to do different things first. And so you can't just say always, always, always do this first, right? So we're just going to talk through these and try to give you enough examples that you have plenty of examples to work with, right? So in this problem, we have the power rule, because we have something in parentheses to a power, right? And we have the product rule because we have variables over here and variables over here being multiplied. So we're going to use both of the rules, okay? Parentheses gives you a clue that the power rule ought to come first. You need to do the power rule first. And remember, everything in a parentheses to a power, each thing in the parentheses has to get paired with the power, right? So we got 2 to the 3rd power, and this is one thing that a lot of people forget that causes them problems. X has to go to the 3rd power, and remember we multiply the powers. X to the 1st power times 3, 1 times 3, right? So then we get x to the 3rd power. Now I'm writing a lot out, and I'm just going to tell you that you're a lot less likely to make mistakes if you kind of write things out and just do one thing at a time instead of trying to do a whole bunch of things all in your head at once. That's where people lead to mistakes, right? And one of the biggest things that you need to do is to be accurate. So it's better to do more steps of writing things down than it is to hold everything in your head and maybe get it wrong. And then also, I can't see what you did wrong to tell you, hey, this is right where you went wrong. Does that make sense? So now we got product rule. which means we have to add the exponents together, right? But now that's only for our variables. We got to remember that for our numbers, we just have to do the math. But this right here, we have to execute and do 2 to the third power first, and then multiply that answer times 2, right? 2 times 2 is 4 times 2 is 8. So this is really an 8, if that makes sense. I kind of like to write it there like that, just kind of tell myself what I'm doing so I don't have to do so many steps. So 8 times 2 is 16. So I've got the number part out of the way. Now I need to combine my exponents for the variables to get the answer. And so we're going to add them up. An x and an x will go together. So we add 3 plus 4 is 7. So we get x to the 7th power. Y doesn't have anything to combine with, so it just stays y to the 4th power, right? So that's the answer to that one. We did the power rule and got our answers for that, and then we did the product rule and got our final answer, and we remembered to just do the math with the numbers like we always do. Okay, over here, our power rule is over to the right. We're going to do this first, and then we're going to add our exponents together with the x's and y's over here. So the first step, I'm not going to do anything to these, but now I'm going to get rid of these parentheses by making everything in the parentheses go to the 2nd power. 2 goes to the 2nd power, and you could just write a 4 there. I'm trying to just be super clear. X to the 4th to the 2nd power means multiply those powers together, so this is x to the 8th power. Okay, now when I'm writing answers over here, notice how this one went. The numbers first, then the x's, then the y's. That wasn't an accident, because I know something that you maybe don't know. When you're writing out answers, you always put the numbers before the variables, and you always write the variables in alphabetical order. So the x is going to come before the y. It's not that it's wrong when you don't. It's just that it's more right, and you're showing that you understand kind of the rules of math, right? Kind of like the same way you are showing that when you stop fully at a stop sign, you really know the rules of driving. Yeah, sometimes maybe you don't have to come all the way to stop because you see that there's absolutely no one around, but you're showing you understand the rules of the road when you do that, right? So now we're going to put the number up front. 2 squared is 4. The x's are going to come first, and we have to add the exponents, 8, 9, 10, 11, 12. So we got that. Sometimes I'll go through and like mark things out as I put them in the answer so I know I've already used them and I don't miss anything. Y to the -3, -3 means it's in the wrong spot. So there's no other y's to combine with. The only thing that's happening with the y is that it needs to move down to the bottom of a fraction. Does that make sense? So we kind of had a negative thrown in that second example, a negative exponent that made us move something around. Okay, let's get on with this. Example number 3. 4u to the 3rd, v to the -2. I don't know why. The program I use uses u's and v's sometimes, and it can be hard to tell them apart, so just make sure you write them really well. On the bottom is 4v to the v u squared. I just already went in and put the 1 there. It didn't show it on the problem when I copied it. But I like to go in and put 1s for the ones that don't have an exponent so that I make sure I don't forget it. Sometimes people just completely leave things out. The variables that don't have an exponent, they just leave them out because they forget them. But if you write the number there, you're a little less likely to forget it because you see it when you're saying I'm adding up the exponents or I'm subtracting them or whatever. Okay? So the first thing I see in this problem is that the 4s are just going to cancel. They don't have any powers to go to. Both of them are just going to stay 4s, and so they're going to cancel out. Okay? Now, I've got this v to the -2 that needs to move into its right location. There's really 2 ways to think about this problem. Like I said, you can either do subtraction with your v's and your exponents and kind of say to yourself, does the answer to the subtraction come out positive or negative? Because if it comes out negative, that means that that variable, whatever the number is, should stay on the bottom. If it comes out positive, it should stay on the top. It's kind of the same thing as thinking about leftovers, but instead of thinking in terms of how many will cancel and where will they be, since these are negatives on top, it might be easier to do the subtraction and use the sign of the answer to tell me where to put the v's, right? So if I have v to the negative 2 and v to the first power, I'm going to subtract negative 2 minus 1. Now some people have trouble with that because they have inherently always had trouble with subtraction of integers when you're minusing, starting with a negative or minusing a negative or anything like that. So that might not be the way for you if that's it. But negative 2 minus 1 is negative 3. So that means that the v's are going to end up on the bottom, right? And I don't see the negative. I came up with a negative in my subtraction, but the negative told me put it on the bottom. If I come up with a positive, that tells me put it on the top, right? So I'm thinking about where it should go and putting it there instead of recording a negative exponent. Does that make sense? So the other is the u's. 3 on top, 2 on the bottom. 3 minus 2 is 1. 1 is positive. That means it should go on top. Okay? Or I could just say the top has more. How many more? 1 more, right? So there'll be 1 on top. Do I need a 1 as an exponent? No. If you put it, is it wrong? No. If you put a 1 as your exponent there, it's fine. It's just, we usually don't. Fourth example, x to the 5th, y to the 3rd power times y. And remember, I'm not really slowing down because if you don't understand or you need to copy, then you need to pause the video and do what you need to do and then pick back up. X to the 5th, y to the 3rd times y, all over parentheses x to the 5th y squared, all of that to the 4th power. Okay? So the first thing we need to do, just like in the first problems, is if we have power to a power, parentheses with a power, we need to give this power to each thing in these parentheses separately by multiplying. And I usually do that before I do anything else because I don't want to get all confused, right? As you get better, it might be easier to kind of do more things at once. But as of now, let's just do one thing at a time, right? X to the 5th to the 4th power, we multiply 5 times 4 is 20. So that gives me x to the 20th power. Y squared to the 4th power is 2 times 4 is 8. That means it's y to the 8th power, right? So now I might want to, and this is what I did on my paper for when I first worked this problem, is to go ahead and think about these y to the 3rd and y to the 1st power, right? Combine on the top to make y to the 4th power. So here's what I did. I just scribbled this one out and made this a 4. Does that make sense? And then I said, okay, now I got an x and a y on the top and an x and a y on the bottom, so now I can figure out where the leftovers are, right? For the x's, there's more on the bottom, right? There's 5 on the top and 20 on the bottom, so 5 will cancel out, leaving 15 x's on the bottom. 5 minus 20 is negative 15, right? And so since that's negative, I put it on the bottom, or I think leftovers will be on the bottom and they'll be 15, right? Y to the 4th and y to the 8th. There's more y's on the bottom than on the top. How many more? There's 4 more on the bottom than there are on the top, so 4 will be left over there. And 4 minus 8 is negative 4, and the negative 4 means they should be on the bottom, right? So either way you think about it, you come out on the bottom. Now sometimes this happens where I've done everything. I've done the x's, I've done the y's, right? There's nothing left for the top. If there's nothing left for the top, you always put a 1 there. So that might be something that we might want to put a little star by and write down right quick. When nothing is left on top, put a 1 there. Right? Sometimes people just leave the answer, x to the 15th, y to the 4th, and they don't even realize that they should be on the bottom of a fraction, and you got to have something on top to have something on the bottom, right? Otherwise, you don't have a fraction. You got to have a numerator. You don't have to have a denominator. A whole number, right, doesn't need a denominator, and it's a fraction with a denominator of 1. That's implied. But the 1 on top can't be implied. It has to show up, okay? Cinco. We're on to Cinco de Mayo. N to the 4th, parentheses, n to the 4th, n to the third. This is kind of a weird problem that has over 2n to the fourth, and all of that jazz is to the fourth power. So the whole fraction, the top and the bottom, is all in parentheses, which means that every single thing in there has to go to the fourth power up here. Now, it is possible to simplify the inside of this first before you do the fourth power to everything, or you could do the fourth power to everything first and then simplify. Either of those ways is fine, right? Because you can see this n to the fourth and this n to the fourth will cancel each other out because they're exactly the same, right? Now, if you do that, I'll just do it both ways so you can see. If you do that, then you can say, okay, the n to the fourths have canceled completely out. They're gone, and so they disappear. So then n to the third to the fourth power, I just multiply. 4 times 3 is 12, so I got n to the 12th on the top. And then I have on the bottom 2 to the fourth power. Now remember, when I have a number to a power, I have to figure out the answer. If you have to use a calculator, that's fine, but 2 is pretty easy. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is n to the 12th over 16. Right? Now if I didn't do that, let's just take a little alternate path. If I didn't do that, I would have multiplied each thing, multiplied the exponents up with the 4, and then did 2 to the fourth power. All of that separately. So I would have had n to the 16th power, n to the 12th power over 2 to the fourth power, n to the 16th power. You could still see that these 16s cancel, but even if you didn't and you added that together and you said 16 and 12 makes 28, so that's n to the 28th power over 2 to the fourth is 16, n to the 16. Okay, now you subtract 28 minus 16, and you get 12. So then you would still have n to the 12th over 16. So there's more than one way to come down to that right answer with exponents, and I wanted to do one where I did it two ways just to show you, like, it's not saying you have to do this in parentheses and simplify, or you have to do the exponent on the outside first. You can do that. There's multiple ways a lot of times to get to the answer, and to me, this over here seems simpler. It seemed simpler to simplify the inside before I did the power, right? But it's not that much more complicated if you do it the other way. So just because you don't do it the same way as someone else doesn't mean you're wrong, right? We're getting into some more complicated ones now. We got y, x squared, z to the third power. I put a little line through my z, so I don't think it's a 2. Then on the bottom, we have 3x to the third power, y to the negative 3, z to the negative 3, parentheses to the negative 2. And I extended my fraction bar line out because the one thing that's big in this is not mixing up your numerator and denominator, but making sure you kind of are always thinking about what was on top, what was on bottom, and that kind of thing. Don't write something out to the side and then execute it improperly, right? So on the top, there's really nothing to be done. Down here, there's things that have negative exponents, and so sometimes when you have a negative exponent, it might be smart to relocate that thing before you start to try to do other things. In this case, all of these things in the parentheses have to go to the negative 2 power, which means I'm going to multiply each of these exponents up with the negative 2, and I'm going to do 3 to the negative 2, right? And so this is the first time we've had a number to a negative 2 power. So there's also two ways to do this. The negative 2, we could just think of this as telling us to move this whole parentheses up to the top, right? Because that's what a negative exponent does, is it moving all to the top, okay? Now, within the parentheses, negatives in there, this negative means takes this parentheses and move it to the top. You're not changing anything in the parentheses, right? So this negative right here would move this whole parentheses up top, but when it moved, the y and the z would still have negative exponents even though they were on the top, because you don't mess with what's in there when you move it. Does that make sense? You only change the exponent from negative to positive when you use that negative to move. We're not using this negative to move or this negative to move this negative is moving this whole thing, but keeping it all the same when it moves it, right? So let's move it and see how that comes out. We still got y, x squared, z to the third up here. That's what was there. Now we're going to move this whole parentheses. 3, x to the third, y to the negative 3, z. Oh, geez, I just have too many negatives written. That's a mistake, not a negative, okay? So this whole thing, 3x to the third, y to the negative 3, z to the negative 3, didn't change. My exponent now should just be a positive 2, sorry. Okay? So I moved that whole chunk. This told me to move this as a chunk to the top. Now I still got to make everything in this parentheses squared. So I need to take it to the power. So I'm going to do that now. Y, x squared, z to the third. None of that changes. 3 has to get squared. What is 3 squared? 9. Let's go ahead and do it. X to the third to the squared is 3 times 2 is 6. Y to the negative 3 squared is negative 3 times 2, which is negative 6. Z to the negative 3 is negative 3 times 2, which is negative 6. So now that we've busted open the parentheses, we did all those multiplications, now we can move these things. The negative is telling me to move y to the 6 to the bottom. The negative is telling me to move z to the 6 to the bottom. Right, so I'm going to go ahead and put me a fraction up here for my next step. And I'm moving y to the 6 and z to the 6 down. Right, I'm taking care of those. Everything else is staying on top for now. I'm going to go ahead and move my number up front because I just like it like that, right? Do we want to go ahead and combine the x's up here and the y's and the z's? The x's are the only things that can combine, and they would come first, so I might as well go ahead and do that. 6 x's and 2 x's, add them together, 6, 7, 8. So see what I mean when I say sometimes it's good to like mark things out so you know what you've done and what you haven't. Y would be next. It doesn't have anything to combine with yet. And z doesn't have anything to combine with on top, right? So now I've moved everything where it ought to be. Now I got to cancel top to bottom, right? There's no other numbers on the bottom, so the 9's not going to change. Does x have any other x's on the bottom to cancel with? No. So it stays the same. The y's can cancel, right? There's going to be some canceling. That's 1 y on the top and 6 y's on the bottom. So there's going to be, when they cancel, 5 y's will be left on the bottom, or you could think 1 minus 6 is negative 5, and that means that the y to the 5th should be on the bottom. So I've done the 9, the x, and the y's, z to the 3rd, and z to the 6th. When they cancel, it's going to leave 3 z's on the bottom. Also, 3 minus 6 is negative 3, right? So that's a different way of coming up with it. So we got 9x to the 8th power over y to the 5th, z to the up. That shouldn't be negative, right? Once I moved it, once it's in the right spot, it's not negative, right? So that's not a negative right there. It's just y, z to the 3rd. So are you getting the gist of it? I'm going to go straight up now to one of the really hard problems, okay? And we're going to do that, and then I'm going to set you free to get started on your homework. And you can ask me questions via text, email, or you can schedule a little Zoom with me if you want. 2x to the 4th, y to the negative 1, z to the 3rd, in parentheses to the negative 4 power, times, parentheses, x, y to the 4th, z to the 4th, all to the 4th power, over y to the 4th, z to the 4th. This is a complex problem, and it took me about half a sheet of paper to do it, but I'm writing out all the steps to be fair, right? I'm not doing anything in my head. I'm just kind of writing everything out to be clear. The first thing I need to do is the power rule with my parentheses that have an exponent outside, right? We have powers inside to a power outside. So we need to move it, make everything go to the power. Now, when we have the negative 4, you do have the option of moving all this to the bottom to the 4th power first, right? But remember, if I multiply with my exponent, each one of these individually will be positive or negative, and then I can just individually move everything. So in this problem, I'm going to go ahead and do the power rule first, and then once I see what each of the exponents is in terms of positive or negative, I can move it, right? So 2 to the negative 4 power. I'm not going to figure that out yet. I'm just writing it to the power. I'm going to show you how to figure this out in just a second. X to the 4th to the negative 4. 4 times negative 4 is negative 16, so X has a negative 16 for its power. Y is negative 1 times negative 4, so now Y has a positive 4 power. Z to the 3rd power times negative 4. 3 times negative 4 is negative 12. So now when I'm multiplying by that exponent outside, it's changing around some of the signs of those numbers, right? So you got to be careful about that. Now, times this. We got X with no exponent, which means 1. 1 times 4 is 4. So we got X to the 4th power. Y, 4 times 4 is 16. Z, 4 times 4 is 16. So I've expanded all that out, and I still got to do not forget to write the bottom. Sometimes people neglect to write the bottom, and then they just keep forgetting it at the end. They've never done anything with the denominator, so don't do that. Okay, what should we do? First of all, I'm going to move everything where it goes, right? Anything with a negative exponent needs to move into its right spot. So I got 3 negative exponents there. Before I combine anything, I'm just going to move everything where it ought to go because that makes it so much easier for me. So I'm going to put a fraction bar here. And first thing I'm doing is moving these 3. This is 2 to the 4th power on the bottom, X to the 16th power on the bottom, and Z to the 12th power on the bottom. Now I'm writing everything else still where it still is. Y to the 4th, X to the 4th, Y to the 16th, Z to the 16th. Now, sometimes people get confused by this. Here's a dot for times, here's a dot for times. But each one of these things, it's really this times this, times this, times this. I'm not writing a dot every time, and in truth, the dot isn't really needed, okay? So I just have stopped writing the dot down here because it's getting confusing, right? So now I've done the Y, the X, the Y, the Z. I got to finish writing this bottom stuff. 2, Y to the 4th, Z to the 4th. Now I wrote the dot there. You know, sometimes do, sometimes don't. It's all multiplication, right? Okay. So now I need to cancel. I need to figure out the number stuff, right? 2 to the 4th power. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So this really is 16. Okay. So now, what should I do first? I think I'm going to record the here. 16 times 2 is 32. I've taken care of this number part now completely. And now I just got to cancel my X's and Y's and Z's, right? Okay. So I might need to think in a little bit of an intermediate way, right? I got Y's here, 4 and 16. 4 and 16 make 20, right? So really I got 20 Y's on the top and 4 on the bottom. So I can go ahead and say to myself, I'm canceling. I got 20 Y's on the top and 4 on the bottom. That's going to leave 16 on top. I could also recognize that this Y to the 4th and this Y to the 4th will cancel each other out completely, leaving 16, right? But 20 minus 4 is also 16. So let's see, where will that be? 20 minus 4 is positive 16, so the Y's will be on top. So now I've got the Y's taken care of. And now the X's. Let's see, got 4 X's on the top, 16 X's on the bottom. 4 minus 16 is negative 12. There's going to be 12 left on the bottom, right? There's 16 on the bottom, right? And these 4 took 4 of these away, leaving 12 on the bottom. So now I've taken care of the X's and Z's. Okay, there's 12 and 4, 12, 13, 14, 15, 16. There's 16 Z's on the bottom and 16 Z's on the top. What happens when that happens? They subtract to 0. 16 minus 16 is 0. But they also completely cancel out, making a 1, right? Are we going to write times 1 down here in the answer? No, because anything times 1 is just itself. A 1 just completely disappears in this case, right? So we got y to the 16th over 32x to the 12th, and that's the answer. Okay, so your homework assignment is the same exact name as the notes assignment. And remember, the notes are due today. If you could please use Cam Scanner to upload your notes. If you can't figure out how to make it and you've gotten notes back from me saying it's not working, then please just text me when you're doing it, because I can walk you through the steps. It's a little different if you have an iPhone from an Android phone. So sometimes the steps aren't working for you, and that's why. Okay, thanks guys. Have a good day.